Good afternoon, everyone. Thank you for taking time out of your day to join us for our webinar on what's new in Femap 11.2, presented by SDA. My name is Martin Civic. I'm the sales director here at SDA, and Eric Gustafson is going to be our analyst who will be doing the presentation for us in the webinar today. I'll wait here for another second or two, and they'll be switching the slides so we can continue forward into the presentation. All right, a little bit about SDA. For any of you guys that are not familiar with us, we are a team of over a dozen engineers. We're located just outside of Washington, D.C., pretty close to Dulles. That includes everything from basic level through developing test plans, advanced stress analysis. At our core, we're a group of stress engineers. So we were founded in '97, and like I said, we cover a lot of the large UAVs, manned and unmanned spacecraft, naval structures, and then we are also a Siemens PLM software reseller. That includes Femap, NX Nastran, Fibersim, which is a Siemens product for developing and managing advanced composite systems, NX CAE, and Solid Edge for 3D CAD. We are also a Siemens first-line technical support certified location. And then one of our other product lines that we do carry is HyperSizer, and that is for the optimization tool if you're dealing in composite and metallic structures. So at this point, I believe we're going to turn the presentation over to Eric so that he can begin the webinar on what's new in Femap 11.2. They've added many enhancements and a lot of really nice features that are going to increase some time savings for you guys when you get started working with the new version. And after Eric gets done with his webinar, if you do have any questions, there'll be you can contact us, myself directly, Eric directly, off our website, through LinkedIn. We have a variety of ways for you to reach our technical support group. So with that, Eric, I'm going to turn this over to you, and I'll let you get started.
All right, thanks, Marty. Thank you for the introduction. I am Eric Gustafson. I'm an engineer here at SDA, and I'm going to go ahead and talk to you guys today about what's new in Femap version 11.2. So the development team has been hard at work at the release, or since the release of version 11.1.2 on some new functionality and updates relating to the areas that you can see here: post-processing, geometry, pre-processing, meshing, and more. Today I'm going to quickly cover a little bit on all of these topics. And like Marty said, if you have any questions, you can submit those during the presentation, and then we'll address those at the end of the webinar. All right, so jumping right into it, what you see here is a little bit about analysis studies. So output sets now can be organized into analysis studies to help order the output data into more understandable groups. These studies can be created automatically when importing or attaching results data or manually from existing data. And this is helping out when it comes to organization. If you've got, in this example here, they've got 5 different subcases for static analysis with a bunch of different results from a modal analysis. And as was before, everyone knows it's all grouped into one listing, and this is going to help you divide and organize that a little bit better to make sense of all of your output. So there's a lot of different ways that you can get those created, and then there's some usefulness once you do have them organized by that. Once you have them organized by analysis study, there's some more utility built in there that I'll get into as well. Now here's the analysis study manager. It's the tool to manage the analysis studies, and this is accessible either through the menu system or the analysis studies context sensitive right mouse button click menu when you're hovering over the output sets. Here you can create a new study or update an existing one. There are controls to delete and copy and activate and deactivate. So this is kind of similar to the analysis manager, but this is completely separate. So your analysis manager still exists. This is just helping with when it comes to organizing all of your output. So here's that context-sensitive menu again. If you right-click on your on an analysis study, you can access the manager and perform a lot of functions such as copy, edit, delete, renumber the analysis studies, and you can also do really fun things like enveloping across all output sets within an analysis study. And then here you can see you've got your options for max, min, max absolute value. So all of those can now be done, all those enveloping operations, that is, can be done on the fly as well. So this is going to be much easier and faster of a workflow, and you can go ahead and do those straight from your output set listing under analysis managers. So you can do this on the fly. So when I say on the fly, that means the information is not stored in your database. It doesn't create an extra output set. It's just kind of created and shown in memory. And you can have options to go ahead and create that information and keep it within the database as sort of like a static output set as well. So I'll be showing that a little bit later as well. So a new result set processing data surface is now available. So like the low case combination data surface, if you've seen that, you can now use that sort of idea on the result sets. So you can apply different factors to each output set and combine them using the spreadsheet like form. And there are two ways of creating that data. You can create all immediately or just as needed. So that's that whole on-the-fly concept for whether or not it's actually saved to the database or not. So here's what the data surface looks like. Again, it's going to be similar to your load combination spreadsheet. And once you have all of the data sets selected that you want to take into consideration, a spreadsheet-like form appears in the data surface editor dialog, and here you can combine, here you can determine the type of combination in the drop-down menus of the operation column. And the types of combinations include linear combinations, max, min, absolute envelopes, and the like. So these new result sets then appear in the model info tree. The icons indicate the chosen creation or storage method, either as needed and temporary, which is going to look like your open envelope there. Here corresponding in the example, like say number 16, or it can be created all immediately, and that's your closed envelope. So it's been a long desired feature to display 1D, 2D, and 3D results simultaneously. In 11.2 you can do that now. Previously you're limited to 2 contour vectors, but now you can go ahead and get a third in there. So everything from bars, plates, solids, you can display the results of all at once, and that should allow for a more complete visualization of results for all element types. So that's a welcomed addition for sure. And for post-processing of complex data, Femap now handles complex data without having to do a lot of transforms. This command is used to take combine a couple different things to process your data, but now it's all done on the fly with this complex results options under your post-processing of complex data menus there. Okay, so another thing that they introduced with 11.2 are these this new freebody display mode called section cut. and that's going to allow for an interactive view of loads throughout your structure, and that'll help you better understand your load path. That's what free bodies really help you out with. And there are a couple of methods to get this going, but generally you'll define a plane or give it enough information to have Femap understand what plane you want the cut to be made at, and it will give you all the information that you need at that interface defined by the plane. So you can put like a summation of your forces or moments along that interface, and I'll show you an example here in a second. But first, there are a couple of ways to actually create that plane, and those are listed here. There's a plane vector, just by vector and by curve. So if you need any help with these, you can reach out to our support team if you're getting started with this, because free bodies can be a lot of work to just get started, because they offer so many different options, and there's a bunch of different ways to view your data. So we can take you through any of these if you need additional help with that. And here's what the result of that section cut looks like. So defined using a plane on a basic wing shape. With this method, you can quickly move along the span of this, in this example, the wing, and see the load transfer at the interface there. And Femap is going to automatically select the appropriate free body nodes and elements based on the plane position. So you can see as it's moved along the span here, it's you can see this, I think the summation vector there. You can see that changes what nodes and elements are selected automatically. So there's on top of this, there are additional slider options. They'll be fine-tuned what entities actually get selected and contained within the free body in order to get all the information that you would need out of it. So it's a really useful new feature to Femap, and just it's going to help make creating free bodies easier, because we all know that can be kind of complex to get started with. So the next thing I want to talk about is the Smart Snap. So this is a new selection method that locates the nearest node, endpoint, curve midpoint, or arc center in Femap. And you can get to this through your right-click menu. Just right-click, and you normally select between point and node. Those are the two most common options. If you change it to Smart Snap, you won't have to keep going back and forth between those two. So that's definitely a big improvement in convenience. Solid slice. We have this new menu in Femap 11.2 that consolidates a lot of the slicing options, and that's going to be simpler when it comes to executing these slices, and offers a little bit more functionality as well. So it's nice to have this one common place to from which you can complete your solid slicing commands. And there's going to be more that you can actually slice with. Now you can slice with sheet solids, and it's just an example is shown there in the bottom left. You've got these complex sheet solids that kind of intersect with this solid bar, and those can now be used to slice that bar to create independent solids. You couldn't do that before with sheet solids, but now you can in 11.2. And kind of following the same theme, you can now use curves to slice solids, and there are some options you can set for how the slicing should actually follow those curves. But that's another new feature. The geometry curve from surface, the washer offset curves, where you go ahead and offset curves from, say, a cutout in a panel. The underlying code for this, this functionality has existed in Femap before 11.2, but the underlying code is now based on a new sort of coding that they've handled on the back end. So the operation to do so is basically calls the Parasol geometry engine instead of a separate Femap routine. So this command was made a little bit more robust between the last version and this one. So now you can define like creating pad and washers using factor or distance for either. So that will help you get the right size of the pad or washer using either one of those offsets. That tends to depend on personal preference, but that option now exists, and you can see that they've added the ability to create a pad around a simple slotted hole as well. So there's some example shots down there. So lots of new welcome features when it comes to geometry modification. Some of my favorites in 11.2 are coming up here. This is the start of some surface editing that they've improved upon. Right here they're showing how you can delete some edges on surfaces now with the with the feature removal tool, and that will eliminate those features from the surface. Next, another big improvement, you can change the shape of a surface simply by moving the points along the edges. So in this example, these three little gusset features are their surfaces of them are changed just simply by moving the points that describe that surface. So if we wanted to run a quick comparison of before and after with the structural behavior with these gussets, kind of with the dimensions that they had before in the upper left versus lower right, it's really easy to do because we'll be able to just pull those points and modify those surfaces directly. It's just not something you could do before in Femap. And here's another modification. You can see by just moving these points along the surface, you can redefine the actual boundaries of the surface, which is a marked improvement because that couldn't be done before. And this is going to help you make all those fine-tuned changes to your surfaces to help with that, with the 2D modeling. Here's a new mid-surface extend tool. So this looks like something that would come out of a mid-surfacing operation. And if we come up with these little offsets between these surfaces of these left and right flanges, and those perhaps they didn't quite meet up with that back surface there, well, we can go ahead and extend that curve to that surface so as to not produce any slivers in our ultimately produce any slivers in our meshes. And along those lines, we can of repairing the geometry created from mid-surfacing. Here's a situation where you can directly edit the point and position of these of the points on the surface so that the two surfaces are able to line up perfectly. So it doesn't require any additional meshing modifications to prevent a free edge at this location. And there's a mid-surface extend tool, the extend tool, extend to set to surface auto curve. So this will automatically select additional curves to select, to extend the surfaces of the entire part with a single selection. So here you've got looks like a box beam connected to a flange, and if it didn't quite meet up before, you needed to extend it to that flange surface, then you can just select one of these curves and to do the extension, and it will automatically move the location of all those curves to be coincident with that surface. The contact, now moving into pre-processing, contact manager data surface enables better visualization of contact definitions. So this will help you keep track of all the potential multitude of contact definitions that one may have if you're dealing with a really complicated assembly such as the one in the example here. So if you've got a lot of different contact regions and properties and definitions there, this will help you keep everything organized. So element thickness. Previously, all this thickness data was stored on the property record. So if you had kind of like a tapered shell element, what you would come up with in Femap would be a lot of different properties So they've eliminated that to be able, so now you're able to store the thickness at each edge of like a two-dimensional shell element actually on the element card itself. So you'd only require one single property to be referenced. So that kind of looks like this. In order to produce the Nastran input file, bulk data file content for all of those elements there, you'd only need one property definition, which is different before for tapered elements within Femap. And there are a couple of additions to the update plate element thickness. There's a new element thickness option to assign thickness to corners, and then you can reset element thicknesses and reset element offset. Previously you had to just set that to 0, but now you can go ahead and just click the button to eliminate any offsets that you may wish to remove from your plate elements or shell elements. So now I'm going to jump into some CBush enhancements. Femap version 11.2 is going to change the way that the information for CBush orientations are stored in Femap. And I'm going to kind of talk at length about this change because it's sort of a big change if you work with CBush elements a lot. So you'll see in this element definition menu, they've added a coordinate system and from property option to the orientation section. So with this first red box on the left here, you can see that we can define the orientation of a CBush element by coordinate system, node, or vector. And this is new because you used to do this, you used to define the coordinate system on the Femap property definition. But when Femap would write this information out to a Nastran file, that coordinate system would be listed on for the CBush card, not for the PBush property entry. So a little bit of a change there to align it better with the way Nastran operates, and you'll see a potential benefit of defining your coordinate system orientations this way in a second here. But there are some considerations to be made that I just want to bring out now. When you import a neutral file or version 11.1.2 into Femap, the CBush elements will have the correct coordinate system still on the property, the Femap property definition. So the model will have the same property as it did before when you import, but when you actually look at the element definitions, it may end up pointing to the vector option. If you did have a vector specified to help you orient a CBush orientation before, or it might the CBush element definition might also just reference the 0 coordinate system, which could be incorrect if you did specify a unique coordinate system for orientations on the property definition before. So there's a little API tool that we have that you can run to set this back. It's actually put out by the Femap development team to kind of switch things back to the way they were. I'll give you a demonstration of that in a second here, a quick little one. But I should also note that if you import from a Nastran bulk data file, all the CBush elements will correctly reference the right coordinate system that was on the element card, and the Femap element definition window dialog will be correctly populated with the right orientation coordinate system. So just to kind of help spell this out, so the import behavior has sort of changed. So if you looked at your model in version 11.1.2, a CBush spring damper element on the left, the element definition would look like that, the left two, and then the property corresponding property definition on the left. You can see how they've got the orientation coordinate system listed here under the property, and that's how you get your orientation for your CBush element. In 11.1.2, if you brought in the same file, it would specify the basic coordinate system. So your information is still correct in the property, that it does specify the right coordinate system for your orientation here, but there's a little API that you can run to get this corrected. And again, this is most useful for people that use CBush elements a lot. So when you run the API, we'll go ahead and reset this from this to this to from property. So then in 11.2, it's going ahead and pulling the information from the property again, like it was in 11.1.2. So that behavior actually might change when they release an update to 11.2, but this is just a quick fix, and it shouldn't prevent your model from running after you run that API. So if you imported a CBush element using a Nastran bulk data file, it would correctly be populated into the element definition dialog under the orientation for coordinate system here. So see in 11.2, you just reference the property. From the property, would grab the orientation coordinate system. And in 11.2, you've now got that option under the element dialog. And in which case, if it knows it's here, you no longer need it under the property. So this is okay. But so that's kind of went into a little bit more detail about that because I thought it was a pretty big change. And I just wanted to help you guys out and make you aware of that. So this change in how they handle the CBush elements was meant to help out in situations where you wouldn't need a new coordinate system, a new property for each CBush element. There are certain situations where you only need one property to define your stiffnesses, and then each CBush element, such as in the cylindrical fashion, can point back to a different coordinate system. So pre-processing element updates. There are some options added to the modify update elements for their directions. So there are a little bit more. There's a little more options for the way you can update an element direction there, and also for the order. If you are using or creating any parabolic elements, you can switch between those with options to delete the mid-side nodes. I don't know if many of you guys use constraint equations, but they now allow more terms within these. These are kind of similar to an RBE, but it's more of a mathematical way of linking degrees of freedom. But now they've, in this latest version, bumped up the limit for as many terms as you can have in a constraint equation. And when it comes to meshing, you can now put a few more elements to your thickness if you're TET meshing. So before it was kind of like a binary thing, yes or no, do you want multiple elements to the thickness of a part? But the TET mesher has been improved, so now you can choose even more, choose to put even more elements to the thickness of a part using the auto TET meshing. The edge split command was given a few more options. Instead of just splitting it, you can now define the number of splits. So I'll jump to an example. If you have this model here where you want to put more elements to a thickness, you don't have any geometry from which to reset the mesh seating on to bump up the number of nodes through the thickness, you can go ahead and do that with the mesh edge splitting. It's a really useful feature. I think they came out with in version 11 or later, and this allows you to make really quick edits on models that don't have any sort of geometry associated with them. It's a really fancy algorithm they have to go through your model and select sort of like a top and bottom, and it will go through and split up all of these elements automatically for you. So really useful. The element quality checks now expand beyond the regular Femap element quality checks. You can see that they've kind of broken this down into 2 tabs. You can now directly check the element quality versus the standards by NX Nastran or Femap. So they're really 2 different ways of assessing quality, and this allows you to, if you have a need to compare directly to the way NX Nastran calculates element quality, you can go ahead and calculate that from within Femap without having to look at any of the output NX Nastran files. And there was some functionality added to 11.1.2 to create a model load from freebody, a really interesting and useful option for working with breakout models, going from a global to a local model. And when they did that, they created this little utility for that purpose, to be able to kind of graft loads from the global model onto the local model with RB elements. So they made this utility for the previous version of Femap that had this model load from freebody command, but they broke it out now so you can use it independently. So it's a nifty little tool to automatically create some RB elements, which are usually a little bit more of a manual effort to create. As with every recent release of Femap, they've improved upon the performance graphics to include more items handled by this performance graphics system. If you don't already have performance graphics turned on, it's under preferences, and it's going to really speed up a lot of your dynamic rotation within Femap. So if you got a really large model, it can really help to have that turned on. A lot of people tend to not even realize that it's there. So that's under preferences, I believe, under the graphics tab. So make sure after this webinar, go check to make sure that you have that enabled, because that can really save you some time when it comes to turning a model around. But not everything is handled by this kind of supercharged performance graphics mode. There's some things that still get rendered in an old method. So they're still displayed the same, but it just takes a little bit longer for some older entities. But now they keep adding more and more under this umbrella of being rendered by the performance graphics routines that they have built into Femap now. And here they are listed. So here's a great example of why you should be using performance graphics. They had a benchmark model with about 1 million elements in it, and just redrawing the model, the complete thing, went from 15 seconds to 1.5 seconds, so a really nice improvement there. Dynamic rotation, getting like an 80x performance improvement just on rotations and the amount of frames per second that are rendered by Femap with that performance graphics turned on. And so they keep adding, again, like I'm saying, more and more entities that are actually rendered using performance graphics with each release. So now you can have a model. If you have nodal loads, say lots of different point forces on your model, they'll be able to render much more quickly now that they've made them compatible with performance graphics. So some more options, some more support options for MSC Nastran contact definitions. They're listed there. If you are someone that uses this a lot, we can send you more notes on this. But they've given you a few more options when interfacing with MSC Nastran for contact. A couple of improvements for solver support with NX Nastran and Nastran in general. In particular, Excel 1 Nastran cards are now compatible with Femap, and Femap titles for connections should round trip to files written out to Nastran. So if you want to bring those back in, you'd be able to retain all the titles that were ostensibly used to help organize all of your connection regions, properties, and connectors. So those using Femap with the NX Nastran as part of that bundle will also see an update of NX Nastran to version 10 when installing. So there are a couple of improvements there in terms of recovered data for laminates and frequency response solutions, and also more compatibility for the advanced nonlinear solutions as well there for PCOMP-G, I believe it's global apply definitions, and for bolt preload. So other miscellaneous enhancements, Femap will now write out models with large number of connection regions much more quickly than before. And here they show that a process that previously took about 9 minutes to write the file now takes something like 4 seconds. And that's really a good point to mention, that if anyone does come across any sort of lengthy operation such as this, please let us know. We can reach out to the development team and inform them. We tend to communicate issues like that to them, and then if we have something that ends up taking a while in a large model of ours, they'll be pretty responsive about getting that fixed for the next release of Femap. That occurs in situations where they just don't have a benchmark on their side as far as having a very complicated model to go ahead and run all their changes on. So stuff like that, go ahead and submit to us, and we'll get it to the team, and it should make it into the next version of Femap. So some geometry changes there. You can now delete surfaces that are part of solids, and what that does is automatically turn it into a stitched sheet solid. So for example, if you had a solid box, a solid geometry, if you deleted one of the surfaces on it, it would turn it into a hollow 5-edged box. Instead of before, it would just do nothing, because that would destroy the solid block. But now it will actually do something if that's what you intend to do. And there's some more compatibility there with solid commands to work with non-manifold bodies. So lastly, if there are some recent fixes for those using the Spaceball or 3D mouse. There's a driver change last year on 3D Connections end that kind of required Femap to respond and change some of their code. And then another bug was uncovered that they worked out with 3D Connection to fix as well late last year. So those are all incorporated into Femap. So that's really going to be it. It'll wrap it up for us today. But before we get into questions, I just want to give a mention to my book that is an introduction to Femap for beginners. We've trained a bunch of new engineers at SDA with this resource, and it has proven to be a big help getting them up to speed. So if you're interested, feel free to reach out to me via email or at that link there. All right, so we'll go ahead and see if anyone has any questions. So I'll just take us a moment here. So it looks like our only question was about getting a copy of the presentation. So this presentation will be available. We can send out a link so that you can access this online following the webinar. We have a question if all 11.2 updates are compatible with Autodesk Nastran. They should be. If you encounter any issues with that, please reach out to us and we'll get those directed toward the Femap development team. But everything should be very much compatible with the Autodesk, formerly NEI Nastran.
All right, everyone. Well, we want to thank you for taking the time again out of your day to check out the webinar. As Eric stated, if you do have any other questions or need any information on any of the products or the enhancements, give us a call, drop us an email. We will get the webinar uploaded and onto our website probably within the next day or two. And there will be a follow-up email sent out to everybody that registered with that link, so you guys can go and view it at your leisure in the future as well. So again, thanks a lot, and have your